Okay, let us continue the lesson. So this is probably the first lesson that usually you haven't seen this before. So this is addition and subtraction formulas in trigonometry. This would be a very long lesson probably, so you have to be patient a little bit. So what do I mean by subtraction and addition formulas? So let us, for example, because I have seen many students tend to think that you can write something like this as sine u plus sine v. So let us start with this news that this is not correct in general. And if you don't mind, people are complaining that u and v are close. So let me change my letters to alpha and beta. So alpha plus beta. So this is the first thing I want you to learn, is that some formula like this is in general not true. Okay? So there is no reason to believe that if I add the angles first and then take sine from the summed value, will be the same if I take sine from each one of them and add the values. In general, this is not true. Of course, there are very few exceptions for some angles that this turns out to be true, but this is not something that you can rely on. Okay, for example, if I give you alpha to be 30 degrees, and if I give you beta to be 60 degrees, yes? If I calculate the left-hand side, what do I mean by left-hand side? It means that I replace alpha with 30 and I replace beta with 60 degrees. But you know that the meaning of brackets in mathematics means that it gives the priority to addition here. So first I have to calculate what is the sum, which is 90 degrees. Then I take the sine from the 90 degrees, which probably you know by visualizing the unit circle, that sine of 90 degrees is 1. But on the other hand, if I calculate the right-hand side, what is the answer? The answer is sine of 30 degrees plus sine of 60 degrees. But sine of 30 degrees, if you look it up in the table, it is 1 over 2, and sine of 60 degrees is the square root of 3 over 2. And then, of course, if I take the common denominator, it becomes this. And hopefully you agree with me that these two numbers are not equal at all. So this is something that I want you to remember. This is false. Again, when I say something is false in mathematics, it means it is not in general true. It doesn't mean that you cannot find exceptions. You can find exceptions. For example, if I choose alpha to be 90 and beta to be 0, this will work, but that is a coincidence. If I choose alpha to be 90 and beta to be 0, 90 plus 0 is 90, sine of 90 is 1. Remember it in your head, the left-hand side is 1. Sine of 90 is 1, sine of 0 is 0, 1 plus 0 again is 1. But that is exception, a coincidence. In general, this is not true. So in this lesson, our first task is to answer what is, if there is, a relation between sine alpha plus beta and sine alpha and sine of beta. So we realize that this formula in general is not true. So the topic of today's lesson is to give you 4 formulas under the title of addition and subtraction. Why formulas? Because we have 2 formulas for sine of alpha plus and minus beta, and we have 2 formulas for cosine alpha plus and minus beta. So these 4 formulas means is known as addition and subtraction formulas in trigonometry. Okay, so if you don't mind, let me clean this so that I can write the correct formulas and see why they are true. Okay, so the correct formulas are these 4. Number 1, if I give you sine alpha plus beta, the answer is not simply sine alpha plus sine beta. It is more complicated than that. It is sine of alpha, but multiplied by cosine of beta, plus the other way around, sine of beta multiplied by cosine of alpha. So you'll see that if you just naively write sine alpha plus cosine beta, you are ignoring these 2 important factors. Okay? And then number 2 is, this is addition formula for sine. we have subtraction formula for sine. It is more or less a copy or paste of the first one, except that the middle sign is negative. So this becomes sine alpha times cosine beta minus sine beta cosine alpha. Okay, and number 3, this is the addition formula for cosine. It is not equal to cosine alpha plus cosine beta, remember that. It is cosine alpha multiplied by cosine beta. And then if you have addition here, you have subtraction here. And then you have sine alpha times sine beta. So you don't need to memorize them. All 4 of them will be given to you in the formula sheet. They are very similar, so you might mess it up. And then, of course, number 4 is cosine alpha minus beta is cosine alpha times cosine beta, but now the opposite sign. So here is negative. The formula turns out to be positive. We will prove them, of course. It is not something that you accept it on faith, you know. So you need to ask why they are true. Okay, we want to prove this. My proof will be a little bit different from the one in the book, because in the book it's always talking about alpha and beta of acute angles. But there is no reason. Alpha and beta could be any sort of trigonometric angles, not necessarily acute. The proof in the book is correct, but it is only for acute angles, okay? But let us prove it in a more general setting. And I will start with number 4. And I use number 4 to prove the other 3 cases. But for number 4, I have to remind you of something that I don't know, might be you have forgotten. Let me remind you of 2 formulas that we need here on this board, and then I come back to the proof. So one formula you need to know from Math 2C, and that is the distance formula. So let me recall. Number 1, the distance formula. So what is the distance formula? Do you remember? If I have 2 points on the plane, x and y, so for example, assume that I have a point with coordinates x1 and y1, and I have another point on the plane with coordinates x2 and y2. If I want to measure the distance, or not measure, to calculate the distance between these 2 points, and let me call it d, you probably remember a formula in Math 2C. So that is, let me write here, d is equal to square root of the difference between x coordinates to power 2 plus the difference between y coordinates to power 2, yes? So this you had it in Math 2C, and this is basically actually the Pythagoras theorem, yes? But there was another formula that I don't know how many of you remember from Math 3C, and that is the cosine rule. So what is this rule telling us, if you remember? It tells you that, so let me just try to tell you. So if you know in Pythagoras theorem, if you have a triangle so that this angle is 90 degrees, if I ask you, can I write A in terms of these 2, which is B and C, you would say yes, A squared is equal to B squared plus C squared. Now the question is that what happens if I have a triangle which is not a right angle triangle? Can I write something similar to this for that triangle? The answer is yes, and the answer comes through the cosine rule, okay? So let me clean this, because in general, I want to write a formula in general, not only for the case when this is 90 degrees. So assume that you have any triangle that you like, of course, including right angle triangles. If this, I call it A, call this one B, and call this one C, the length of the opposite side I denote it by little a, the length of the opposite side here B, and the length here is c. Cosine rule in the last lesson in Math 3C, if you remember, tells you that a squared, this one squared, is this one squared plus this one squared, similar to the Pythagoras theorem, but it is not finished. If it is Pythagoras, if it is right angle triangle, this is the finished, but it is, in general, it is not finished. What you need to do, you need to write minus 2 times b times c, these two sides, multiplied by the cosine of the angle between these two sides. Yes? Between side b and c, the angle is a. So I have to multiply it by cosine of a. And I have already, by the way, uploaded the formula sheet, so you can check if this is included in the formula sheet for Math 4 or not. It is on Google Classroom. And I think these formulas are already there. Okay, so for example, here, if you want, you can write something for b squared. B squared is a squared plus c squared minus 2 times a times c, but multiplied by the cosine of the angle between a and c this time, which is b in this case. Okay? And similarly, you can write something for c squared as well. So c squared is a squared plus b squared minus 2ab times cosine of c. So this is called the cosine rule. The proof of the cosine rule, if you remember, is dependent on the Pythagoras theorem. So you use Pythagoras theorem 2 or 3 times, I don't remember, we have to do it. And then you can find these formulas. But anyway, I don't want to go through the proof of these. I am taking them for granted. I want to use them to prove the new formulas for you. Okay? Okay, as I told you, I will start with number 4. Okay, so proof number 4, yes? Okay, so let me just draw a unit circle. And then I have 2 coordinate axes here, x and y. Let me consider 2 points. For example, let me consider that this point corresponds to alpha, because I have 2 angles, alpha and beta. I don't know, I have to draw some picture for definiteness, but my argument does not depend on the details of the shape. So assume that from here to here is alpha. Okay, and then, for example, I don't know, from here to here is beta. Yeah, so that is beta. Okay, now if I ask you, can you read the coordinates of this point for me? The answer is yes. What are the coordinates? The x coordinate is the cosine of the angle, which is alpha in this case, and the y coordinate is sine of the angle. And if I ask you what are the coordinates of this point, you will more or less say the same thing. So it is cosine beta and sine beta, yes? Okay, now if I ask you what is the angle between this red line segment and this blue line segment, what's the angle between these two lines? From here up to here is alpha. From here up to here is beta. So if I am interested in the angle between them, what is that? Yes, which is alpha, the bigger one here in this case, minus beta. So this angle is alpha minus beta. Okay, if you don't mind, let me give some names here. So the origin, I call it O. This point, I call it A, for example, and this point, I call it B, yes? This, I call it B. And then what I do, I connect these 2 points together from A to B. My point, my strategy is to calculate the length of AB in two different ways. Once using the distance formula, second using the cosine rule. Okay, but if I am calculating the same quantity in two different ways, these two numbers should be the same because I am calculating the same quantity. Okay, so let us just do that together. Okay, so let me call AB to be D. Let AB to be equal to D. Okay, in this picture. By the way, if I ask you what is the length of OA, you already know, because that's the unit circle. So the length is one length unit, and the length of OB is also one length unit. My goal is to calculate D in two different ways. First, using the distance formula. Okay, so this tells you that if you want to calculate the distance between 2 points, what you need the coordinates of the endpoints. I already have them. One of them are this, one of them are this. Okay, so what is D then? D is a big square root sign. The difference of the x coordinates, these two, the difference between them squared, yes, plus the difference between y coordinates squared. Okay, I want to simplify this, but let us do some part of it in our head, yes? I hope that you can follow. If not, I can just clean it and then write it again. So if I want to simplify this, I have to expand this, and I have to expand this. So when I expand this, I will get the first one squared minus 2 times the first one times the second one plus the second one squared, and I will get the similar thing here. But look, the first one squared here is cosine alpha squared. If you are a little bit patient and reach to this part, this will be this one to power 2. So I will get a cosine alpha squared from here. Later, I will get a sine alpha squared from there. So if I add them, I know what the result is. What is that? Yeah, it's 1. So I hope that you can follow. So let me just save some time. So there is a 1 coming from these two terms. Is there another 1 coming in? Yes? Do you see another factor of 1, another term 1 here? Because this 1 to power 2 will eventually follows, yes, which is cosine beta squared. And if you are patient, some point later, you will see sine beta squared. Yes, agree? Everyone understand what's going on? So that cosine squared and sine squared of the same angles again gives me another 1. Yes? And now this will give me minus 2 cosine alpha cosine beta. This will give me minus 2 sine alpha sine beta. So I can factor a minus 2 out. And then what is left is cosine alpha cosine beta plus sine alpha sine beta. Yes or no? Happy with this result? Okay. And of course, 1 plus 1 is now 2. And then I have another 2 here. I can pull a 2 out. Yes? So what happens? Okay. So if you don't mind, let me square both sides because I want to get rid of a square root sign. So the left-hand side becomes d squared. The right-hand side, I have 1 plus 1, which is 2. And then I have 2 minus 2 cosine alpha cosine beta plus sine alpha sine beta. So this is a little bit promising, yes? Because the formula that I want to prove, on the right-hand side, you see exactly this combination. So at least it is promising that we are not completely on the wrong track, yes? Okay, now let me calculate this part. So what I do, I move this term to the left and d squared to the right. So this becomes 2 cosine alpha cosine beta plus sine alpha sine beta. And on the right hand side, I will have 2, and I move d squared to the left, it becomes minus d squared. And I divide everything by 2 because my goal is to calculate this. So I will get cosine alpha cosine beta plus sine alpha sine beta. I divide everything by 2. The right hand side becomes 1 minus d squared over 2. So this I keep it for the future. So this is number 1. So you see, I calculated this combination that I need using the distance formula in terms of the distance between these two endpoints. Any questions so far? And by the way, when I talk about proofs, because if you want to learn mathematics, it's good to know where the formulas are coming from. But for the exam part, you don't need to read. If you don't like it, you don't need to follow them. But you need to know how to use the formulas, okay? So number 2, I want to use the cosine rule. Okay, can you help me? The cosine rule is here in front of you. And I want to use these cosine rules, one of them, to calculate d squared again. So it is clear that to use the cosine rule, I need a triangle. So which triangle is a good candidate here? Triangle OAB. Yes, so I will write the cosine rule in this triangle. So what will be the answer here? So OAB. In triangle OAB, I want to write the cosine rule. The cosine rule tells you that if you are interested to this number squared, which is d squared, it becomes this length to power 2, which is 1 to power 2, plus the other length to power 2, which is again 1 to power 2, minus 2 times 1 times 1 times the cosine of the angle between these two sides. Yes, between this one and that one. We already answered that. That's exactly alpha minus beta. So this becomes cosine alpha minus beta. Yes? Let us do some simplification. So this is d squared. 1 squared plus 1 squared is 2. Minus 2 times 1 is again 2. Cosine alpha minus beta. Then I move this to the other side. It becomes 2 cosine alpha minus beta. I move d squared to the other side. And I divide everything by 2 once more. And I think everyone agrees that we are done now, yes? Now compare what is happening. The same quantity 1 minus d squared over 2 appears here and there. So these two quantities are different, but both of them are equal to the same quantity. So then I have to admit that these two are the same, yes? So this means that from comparing 1 and 2, I can conclude that cosine alpha minus beta is indeed equal to cosine alpha cosine beta plus sine alpha sine beta. So that was the proof of number 4. Yes, so this is the proof. Why this is working, this is the reason. Any questions? Okay, so far, one of these formulas are clear. Is everything clear? Okay, now, proving number 3 is very simple. We don't need to do something similar to this all over again. Can you tell me how can I prove number 3? Assuming now that we already, not assuming, we actually showed that. Number 4, we now know that formula 4 is correct. I want you to tell me how I use this fact to prove this one. It doesn't involve geometry at all. So you don't need to even visualize any pictures or something. Just think about this formula. How can I go from this formula to this formula? Any ideas? By the way, this is important. It's not hard. Alpha plus beta is the sum of 2. numbers or angles, and alpha minus beta is the difference. Always addition can be written as subtraction. Subtraction can be written in terms of addition. How? If I tell you a minus b, I am subtracting two numbers. But if I insist to write this as a sum, it's the difference. But can you write this difference as a sum? Yes. What is the answer? You write a plus, but minus b. So the left-hand side is a difference, the right-hand side is a sum, but they are the same, yes? Or if I give you plus, can you write it as a difference? How do you write it again? A minus minus b. So this is a very important simple rule to be in your head, yes? A difference can always be assumed to be a sum, and a sum can always be assumed to be a difference if needed. Okay, and this is needed because the formula, I know the formula for the difference. I want to discover a formula for a sum. Okay, so if I interpret the sum as a difference, my question is to answer this, of course, but I told you that every sum can be viewed, if needed, as a difference. Do you agree? So instead of alpha plus beta, I can write alpha minus minus beta. For example, if you don't mind, you can call this b. And then what do you see? You see cosine alpha minus b instead of beta. But you already know the formula there. So what is the answer? It becomes cosine of the first one times cosine of the second one. Minus becomes positive. I am using formula number 4, so let me write it here. And then it becomes sine alpha, sine b. Yes? Is that clear? Okay, but now I need to switch back to my original variable. There was no track of b here. I introduced b to be able to solve my problem easier, but whenever it is done, I have to switch back to old variables. Old variables mean alpha and beta, so I have to get rid of b. But what is b? B is the name for minus beta. So I replace it back. So it becomes cosine alpha times cosine minus beta plus sine alpha times sine minus beta. But hopefully you remember the topic of the previous lesson. Do you remember we talked about the trigonometry of opposite angles? But I don't know how many of you remember. What was the formula for cosine of the opposite angle? Cosine of minus theta is equal to cosine beta, and sine minus beta is negative. So exactly. So that's why this minus sign doesn't have any role. It actually absorbed. So this becomes cosine alpha, cosine beta. But this minus sign will go out. So then instead of putting it here times minus, I put the minus here. And that is exactly what you wanted to show. Number 3, we are supposed to show this expression is equal to this expression. So proof of number 3 is also done. Yes, so we already know number 3. Okay, now we want to prove number 2 and number 1. But now we have 2 formulas at our disposal. We want to use them, whichever is suitable, to prove one of those formulas. Might be that is a good idea. Okay, it doesn't matter which one we start with. So let us go in order. So let us go to number 2. So we want to prove number 2, yes? Here. Do you have any idea? How do you think I should be able to prove number 2? What's the question? I want to prove number 2. So you want to say something about sine, but you have your information about cosine. So I told you that there are two important formulas that you can switch back and forth between sine and cosine. What are those formulas? One of them is the fundamental identity, sine alpha squared plus cosine alpha squared is 1. It will enable me to switch back and forth between sine and cosine, but the weakness here is that I should have a power of 2. Otherwise, I am in trouble. This is one way. You should have these things in your mind as anchors, yes? So because you need to have something in your hand to be able to think. So that is not probably a good way to do it here, because then I have to work with second powers and then square roots. Another one is that, so there are two standard ways, going from sine to cosine, cosine to sine. This is probably not working. The second one is, I have repeated it many times. Yes? Exactly. So that is the complementary angle, yes? So I go, for example, number 2. So I would say that sine alpha minus beta is what I am interested in. But the information that I have is number 3 and number 4, which are related to cosine. So it might be motivating me to write, if possible, this sign in terms of cosine. So this means that if this comes to your mind, then what happens, you write cosine, but you write it with the complement angle. So I think it's better to work with degree here, not to confuse you. First of all, I want to make sure that you really understand what I have written on the board, yes? Sine of an angle is equal to the cosine of its complement, yes? But how this might be useful? Any ideas? Because now I can multiply this negative sign in, so let me just write it. So it becomes 90 degrees minus alpha, but minus alpha becomes plus beta. So at least this is a good progress, because now I wrote sine in terms of cosine of such a combination. But there is one weakness here. How many angles are involved? 3, 90, alpha, and beta. But number 3 and number 4 are dealing with 2 angles, alpha and beta. But that is not a big obstacle, yes, because if I write 3 numbers for you, this is the sum of 3 numbers, but you can view it as the sum of 2 numbers if you want to, yes? By putting A and B in one pair of brackets and then plus C. This is the first number, this is the second number. Yes, I can do the same thing here by giving the roles. If you don't mind, let me call it, for example, A. Then I will have cosine A plus beta. For cosine A plus beta, I can use number 3. So I use number 3. What happens? It becomes cosine of A. So let me write A times cosine of beta. I'm using number 3 minus sine A sine beta. Yes? But I have to switch back to my old variables. I brought A in to be able to solve my problem. When it is finished, I go back here. So what do I mean I go back? Instead of A, I write 90 minus alpha. So this becomes cosine of 90 minus alpha times cosine beta minus sine 90 minus alpha times sine beta. Yes? Sorry, I have to put the degree sign here. But now tell me again, can I write something simpler than cosine 90 minus alpha? It is sine alpha, yes? Do you agree? Sine of an angle is equal to the cosine of its complement. And then I have cosine beta here. And again, sine of this angle is equal to the cosine of its complement. And then multiplied by sine beta. And that is exactly formula number 2, yes? Sine alpha minus beta, which is this, is equal to sine alpha cosine beta minus cosine alpha sine beta, which is exactly the same combination that you see here. So this is also the proof for number 2. But can you tell me how should I go to number 1 now? It's very, very simple now. I want to go to number 1 and everything is finished. I don't want to go through it because it's very simple. You already know the trick. Can you tell me what should I do? What changes I have to make to alpha minus beta to make it alpha plus beta? What I need to do is to replace beta with minus beta, yes? So in this formula, I replace beta with minus beta everywhere. I don't want to write it down, but I will explain it orally, okay? So if I do this change, this turns to alpha plus beta, which I need in number 1. And then this turns to, so this is the same, but beta goes to minus beta. But cosine of minus beta and the cosine of beta are the same. So the first term will not be affected. But if I change beta to minus beta here as well, then it becomes negative sine beta. That negative sign will cancel this negative sign, it becomes positive, and this is the reason that you see positive in between. Yes? So anyways, if you are interested to see at least once where these formulas are coming from, this is the complete proof. Otherwise, you need to learn how to use them. Okay, so these formulas will extend our ability to calculate exact values for some other angles. So let me start giving examples. If you remember, in the previous lesson, by the way, in Swedish books, I haven't seen formulas for tangents because we will have 2 formulas for tangents. So what are the tangent alpha plus beta and what is tangent alpha minus beta? These are not part of the book, but I will talk about them a little bit as exercises, but they are not in the formula sheet. So let us try together. If you remember in the previous lesson, I gave you a little bit hard example, and in that example, I told you assume that tangent 75, if you go back to your previous notes, you see that in one of the exercises, the last exercise we solved last time, I told you take this for granted that tangent 75 is this number and then try to answer another question. But now, using these formulas, we can prove this ourselves. So in principle, I can give you the table. Without giving you this piece of information in the previous session, I could ask you to solve that fraction, okay, to find the exact value. Okay, so now my question is that, why this is true? Okay, I want to calculate tangent of 75 degrees, and I told you that you are not allowed to use the calculator. By the way, you can also test. I think Texas Instrument will always gives you back a decimal number, which is not the exact value. But if you have Casio, I think I have checked it before with the Casio calculator, it gives you exactly this answer. So if you write tangent 75, it gives you 2 plus the square root of 3. Okay, now assume that I just give you the formula sheet, which includes that long table of values, but not 75. 75 is not among them, yes? But you need to use the information there and these formulas to be able to calculate tangent of 75 degrees. The first thing that comes to mind is that, okay, I do not have any formula for tangent here. But that is a minor problem. Why? If you want to calculate tangent, yes?
You can write it as
over cosine. Yeah. So it means that I have 2 tasks. Calculate sine 75 individually, separately, and cosine of 75 separately, and then divide. Yeah, so that is actually a strategy, is clear. But so it means that to answer this question mark, I need to answer 2 questions. I need to ask myself, what is this number, if possible to calculate, and what is this number? Hopefully you agree that if I can answer these 2 questions, I am done. Okay, so, but how can I calculate sine of 75? This is why I've told you that even if you don't remember the formulas, you need to remember which angles are famous. So do you remember? How can I write this somehow relating to 2 famous angles? So the famous angles are 0, 90, whatever. Yes? 30 plus 45. Yes, because 75, of course 75 can be written in infinitely many ways. I can write it 70 plus 5, but even though that is not wrong, but it is useless because I don't have information about them. So the only thing that I have information about is 30 plus 45. Yes? So this is a good starting point. So if you tell me what is sine of 75 degrees, and you give me that table, then I realize that 75 can be written as 30 degrees plus 45. Again, am I allowed to write sine of the first one plus sine of the second one? No, that's the wrong way of doing it. The correct way we learned today, and that is, let me just make sure, yes, it is here. So that is the formula number 1. So let us write this patiently, okay? So this becomes the sine of the first one. I always remember it like this. Sine of the first one, cosine of the second one, plus the other way around. Plus sine of the second one times cosine of the first one. Yes? Okay, and then if you don't have it in your memory, you can see it in the table. Sine of 30 is 1/2. Cosine of 45, there are two ways of writing. Do you remember? I always prefer the one without having the third sign in the denominator. I think in the Origo book, they have written it like this, but I showed you when I was teaching, these two numbers are the same. And then plus. Sine of 45 is the same as cosine of 45, multiplied by cosine 30. Cosine 30 is the square root of 3 over 2. And let us simplify. So the first one is the square root of 2 over 4. The second one is the square root of 6 over 4. So we got sine 75. So sine 75 degrees is equal to, the denominators are the same, so let us take the common denominator. So this is cosine 75 degrees. Now I want to calculate cosine of 75. So cosine of 75, which formula is useful? If you want, I can write the number of the formula. So this was formula number 1 I used. Here I will use formula number 3. So no, sorry, not here. After that. Cosine of 75 is cosine again 30 degrees plus 45 degrees. And then it becomes formula number 3. Cosine of the first one times cosine of the second one. But for the case of cosine, the signs are opposite. If it is plus, you need to write minus here. And then you write the same thing for sines. And then put the numbers in. Let me just do it quickly because they are the same numbers. This is a square root of 6 over 4, square root of 2 over 4. So this becomes square root of 6 minus the square root of 2 over 4. So we also got cosine 75 degrees. Okay, and then I need to calculate the question mark, which is tangent of 75. But everyone knows that tangent is sine over cosine of the same angle. I have already calculated each one of them. So instead of sine, I write this. And instead of cosine, I write this. We have to do, because this is completely correct, you can simplify these two 4s, and then the answer that you get is really correct. But that is not exactly what is demanded in the problem. In the problem, they ask you to show that this is so simple. I'm not saying this is hard, but it's harder than this one. Okay, so the rest of it is just algebra. But today's lesson is finished here. Okay, so this is completely acceptable solution. I don't know, do you have any idea how to simplify this? Because the goal is to show that this one at the end turns out to be this number. I hope that you agree this is much simpler form of that. For example, in the numerator, can you see that I can factor something out? I have square root of 2 plus square root of 6. What can I pull out? Square root of 2, yes? From this one, 1 is left. From this one, how much is left? Is a square root of 3. Do you agree? Because if I multiply back, this will give me this term. If I multiply it back here, so that factorization is valid. And I can do the same thing here. I can factor a square root of 2 out. From here, square root of 3 is left. From here, minus 1 is left. At least square root of 2 and square root of 2 are factors common. They are gone. So I get square root of 3 plus 1. It doesn't matter in which way I write it. And this is square root of 3 minus 1. First of all, do you agree that this one is better than this one? But still, it's not the answer demanded in the problem. And I taught you the trick last time. I don't know how many of you remember. So you see there is a surd sign in the denominator. And I told you usually it is better to get rid of surd signs in the denominator. And there was a standard trick for doing this and using the conjugate rule in an appropriate way, yes? So how should I do that? So let me just write it here above. So this is a square root of 3 plus 1 square root of 3 minus 1. So I told you that rescale it by the conjugate of the denominator. The conjugate of the denominator is this combination. So hopefully you agree that I have done nothing, because if I ask you what this number is, you would say it is 1. So I have just multiplied this number by 1, which is exactly the same number. But what is the benefit of doing that? You immediately realize this number multiplied by the same number, which is a coincidence here, it becomes that number to power 2. But this number times that number is the conjugate rule. So this becomes the first one squared minus the second one squared. And then I will expand this, so this becomes the first one squared plus 2 times the first one times the second one plus the second one squared divided by, this is 3 minus 1. So the numerator 3 plus 1 is 4 plus 2 square root of 3. 3 minus 2 is 2. And I factor a 2 out, so it becomes 2 plus the square root of 3 and then divided by 2. So this 2 and that 2 are gone. So that is the answer that I get at the end, which is exactly this answer. But for the exam, for the case, the rest of it is to make it sure that the number that I got is exactly this number. And from here to here is just the proof of this. But if I ask you just to calculate this exact value of sine tangent of 75, that is enough if you stop there. Yes?
Oh, you wrote that 1 to the power of 2 is 2.
Yes.
Isn't it
No, you don't. Oh, yeah, okay, okay. I answered here correctly. Thank you very much. I don't know. Yeah, the answer is correct. Thank you. Okay, so this is one of the, for example, let me ask you if you want to calculate, for example, let us not calculate tangents, of course, because this is a little bit lengthy. But if I ask you what is sine of 15 degrees, can you calculate that? So the second question, what is the exact value of sine of 15 degrees? Again, you need to connect this 15 degrees somehow to the famous angles. For example, I cannot ask you to calculate sine of 20, because 20 is not related to any of those famous angles. Yes? It doesn't mean that we cannot calculate, because calculator knows how to do it. So there are some mathematics behind the program for the calculator. But this is not part of a lesson. But sine 15 is exactly at the right level for your knowledge, like sine 75, like cosine 75. So how can I calculate sine of 15 degrees? Yes? This is one possibility here. There is also another possibility here for this case. Yes? Okay, yes, but we don't know that formula yet. We don't have we will come to that, but we don't have that formula. For example, what do you know? So what he is saying is that you have an angle, you divide it by 2. Okay, so what can I write in front of it? If you attempt to pull 1/2 out, let me just correct you. This is not the case that 1/2 goes out. Yes. So this is not the rule. Do not invent new rules for yourself unless you have a reason for that. Okay, so this is not working. But what you said is working. But there is another option here in our case. So you said what? You said 45 minus 30. So he's saying that use 45 and 30 as a difference, which is completely correct and useful. Why? Because I know everything I need for 45 in that table. I know everything I need for 30 in that table. And the good news is that the difference of them is 50. So that's good. So you might start calculating using this formula. I might start calculating this using another relation. Do you remember what is that? Can you tell me? 60 minus 45. That's also working, yes? Because I coincidentally also have information regarding 60 and 45. So some of you might start from this, which is 100% correct. Some of you might start with this. The intermediate steps are different, but the final answer should be the same. We can check it. If I want to calculate using this, in each case I have to use formula number 2. So this becomes sine of the first one times cosine of the second one minus sine of the second one cosine of the first one. Okay, so these numbers, I have it in my memory. So this is the square root of 2/2. This is 1/2. Oh, sorry, square root of 3/2. And this is 1/2. And this is the square root of 2/2. So this multiplied by that is a square root of 6 divided by 2 times 2 is 4. That is square root of 2 divided by 4. So that is the correct answer for sine 15. By the way, in principle, if I have already given you this, in a matter of seconds, you should be able to answer this. Why? But of course, it depends to this calculation. Because 15 and 75 are complementary angles. So sine of one of them is equal to the cosine of the other one. And then you see that this is exactly the same number. But this is not a good way because in the exam, you do not have access to this. You have access to these two or these two. Okay, let me just do this one here. If you use this formula, so this becomes sine of 60 cosine of 45 minus sine of 45 cosine of 60. But again, sine of 60 is the square root of 3/2. Cosine of 45 is this number. Sine is also the same number. Cosine of that is 1/2. So you see this intermediate step is different from this, but the numbers are such a way that the answers are the same. It becomes the square root of 6 minus the square root of 2/4 again. So it doesn't matter which one you use. Yes? Okay, the next part of the lesson are the double angle formulas. Okay, let us keep the formulas. Okay, so that is also very important. So let me write it here now. Double angle formulas. What do I mean by double angle formulas? I mean, if I give you theta and I multiply it by 2 to generate double angle, and take sine of this or cosine. By the way, usually you don't need to put these pairs of brackets. In the book, they haven't put that, so let me just remove that. But again, let me just, in the beginning, write it and cross it over. So if you still believe that you can take these two out, that is wrong. I really recommend you to write it and cross it over. And the same thing is not correct. But again, when in mathematics I say it is not correct, might be you can find some exceptions. But in general, it is not true. Because this is a common mistake, I really recommend you to write it down and cross it over. These are not the correct formulas. But in principle, you should be able to discover the formula yourself now. Can you tell me how can I discover a formula for sine 2 theta? Using one of these four formulas that you see. How can I do that? What can I write? So that one of these formulas become handy and useful. What is the meaning of 2 theta? Yes, this is theta plus theta. So this becomes sine of theta plus theta. Yes? Because theta plus theta is exactly 2 theta. But now if you look at the first formula, you are done. That if you compare this, what you need, with what you have, is that instead of alpha, you put theta. Instead of beta, you also put theta. Yes, so what happens on the right-hand side, instead of alpha and beta, both you have theta. So this becomes sine of the first one, which is theta, times cosine of the second one. But the second one, coincidentally here, is the same, plus the other way around. The other way around means sine of the second one, which is again theta, multiplied by cosine theta. Yes? So in this special case, the terms both become the same. And then, of course, no one writes like this. People usually write it as 2 times sine theta, cosine theta. And now it is important to compare again. You see, it was not complete. You see, I pulled 2 out here. If I stop here, that is wrong. I have to remember to multiply by this cosine theta. So this formula, this is also in the formula sheet, but I will add it here for you. So 2 sine theta cosine theta. So this tells you that how you can relate cosine of double angle, for example, 30 degrees. For example, if you want, you can write something like this. For example, if I ask you sine of 30 degrees, of course, this is not hard because you already know the answer to sine of 30. But if you want to, you can write it as 2 sine of half of this angle. You see, whatever angle you have here, the angle that you have here and here are half of this angle. This is important. By the way, this is important interpretation. It doesn't mean that it has to be 2. No, whatever angle you have here, you can divide it by 2 and put it here and there. That is the interpretation of this formula. So you have sine of 30, you can divide 30 in 2, becomes 15, put 15 here and there. Okay, so I don't need the, okay, I can take this away. You don't need it. But let me just emphasize again on it because I know that this is a little bit confusing sometimes. Can you write a formula for this one for me? Yes, I just want you to know that in the formula sheet you get only this version. But it doesn't mean that if you need that formula in this context, you are not allowed to use it or whatever. Yes?
So you put in 2x plus 2.
Not x.
Not x, but I forgot the name of the
Theta. Yes, exactly. So this is important, how to interpret this. This tells you that sine of an angle is 2 times sine of this angle divided by 2 times cosine of the same angle divided by 2. So if it is 2 theta, when I divide it by 2, theta is left for me. But if it is 4 theta, if I divide it by 2, what happens? It becomes what? 2 theta, but multiplied by cosine 2 theta. Okay, if you insist, you can continue. For example, again, use the same formula for this part. Yes, for example, what can you write? You can write 2, and then I can copy and paste this part. For the time being, we do not discover the formula for this. We will do soon. But here, again, what can I write? I can write 2 sine of this angle divided by 2 times cosine that angle divided by 2. And if I want to write it a little bit more compactly, I multiply 2 by 2. It becomes 4. 4 sine theta, cosine theta, and then cosine 2 theta. Yes? Yes?
I have one question. If you did 4 sine theta cosine theta, would it work then?
Yes, it becomes 2 times that number. So if you have 4 sine theta, cosine theta, by the way, this is a good question because you need to be able to go back and forth. In some problems, you have this one. It is needed to break it into smaller parts. But in some problems, this is given. You should be able to combine them back into one formula. So in this case, of course, this number shouldn't be 4. This means if it is 4, you need to interpret it as 2 times 2. And then this part becomes sine 2 theta, but there is a 2 here, so this becomes 2 times sine 2 theta. In that case, it is your answer. Yes? I will come back to these things because it needs a little bit of examples to understand this fully. But before doing that, let us discover another formula for cosine of the double angle. But this is easy now, hopefully. You know what to do for discovering that formula. But there are 3 formulas for that. All of them are given in the formula sheet, but in principle, they are one single formula. Let me just describe it for you. So how can I find a formula for cosine of 2 theta? I use formula number 3. Instead of 2 theta, I write theta plus theta. And then I use this formula, yes? Here, theta is playing the role of alpha. This theta is playing the role of beta. So this becomes cosine of the first one times cosine of the second one minus sine of the first one, sine of the second one. But the cosine times cosine is cosine squared theta minus sine squared theta. So this is the formula. I will write it down here. And then be very careful here because there is only a minus sign difference with the identity we have. If this minus sign were a positive sign, the answer is always 1. But if it is a minus sign, there is not a particular number. Cosine comes first. Be careful because the minus sign is sensitive to the order. Cosine theta squared minus sine theta squared is cosine of the angle times 2. Okay? So it doesn't hurt if you just remind yourself here that cosine 2 theta plus sine 2 theta is 1. Okay. Let me write the other two formulas, then probably we will stop. This doesn't mean the lesson is finished because I need to give you more examples so that you can understand the problems better. But there are two other formulas. If I ask you to calculate cosine of 2 theta, again the interpretation is the same. Be careful. It doesn't mean necessarily that it has to be 2 here. If I have 4, I divide them by 2 and write them here, so it becomes 2 theta. Yes? So if I ask you what is cosine of 4 theta, you can write cosine to the power of 2 theta, minus sine to the power of 2 theta. Okay, can you tell me this one? Can I split this also as well? Yes?
You can just write 0.5. No, mind. It will not work.
No. So cosine theta. So I told you that whatever angle you have here, if you want, for some reason, to use this formula, you can, but you need to remember the angle that you put in front of these two should be this angle divided by 2. Okay, so in this case, if you insist to use this formula, you can do, but you can write cosine to the power of 2. What should I put here? This angle divided by 2, yes? Which of course, sometimes might be good. But this is not usually good because you are writing something simpler in a more complicated form. But you need to understand this formula, or that formula, they are not different formulas. They are the same formulas, yes? Is that clear? The same for sine. If I insist to write sine more complicated, you can. How do you do that? You write 2. Which angle I have to put in front of sine and cosine? Whatever you see here, divide this by 2 and put them here and there. So here now I see theta, so I divide it by 2, so it becomes theta over 2, and then cosine theta over 2. Okay? This is, by the way, useful because I am not usually making simple things harder, but you might face a problem that you have this one, then you need to realize that, okay, I can combine all of them to a simpler formula. So it is important to be able to go back and forth. Okay, so let me just finish this one because Morten has actually warned me to finish on time this time. So you are supposed to have this Daniel to talk about the London trip, yes? Yes.
Write 0.5 times theta.
Yes, you can, but usually I don't do that. Yes, but that's not wrong. Yeah. Okay, just be patient a little bit so that I can finalize this. So cosine 2 theta. Okay, just give me a little bit of time to finish this. So sometimes, if I ask you to calculate cosine 2 theta here, I have to give you cosine and I have to give you sine. But if you want to, instead of cosine squared, you can write 1 minus sine squared. Okay? And then you can just copy and paste the rest of it. So it means that I want to get rid of cosine in favor of sine. It is not, you don't have to do this, but sometimes this is more suitable. And then minus sine 2 theta and minus sine 2 theta, it becomes minus 1 minus 2 sine 2 theta. Okay, so I will add a formula here below it. So if you don't mind, let me just remove this now. Okay, so I will continue. This is also possible. In some cases, you can use this formula. And by the way, be very careful. If I just write 1 minus sine squared theta, the answer is cosine to the power of 2 theta. It's better to compare these formulas, okay? But now if I have an extra 2 here, it becomes suddenly cosine, but instead of power 2, you have 2 times theta. It's better to write these formulas so that some next to each other, so that you can compare and don't get confused. This is actually very, very formal. Even in Math 2C, You have probably seen that, but this is something that we just learned, okay? Okay, one more formula that I want to continue. I clean this. Okay, the lesson is not finished yet. Hello? Okay, and then we go here. Instead of cosine squared, this time I write cosine squared. But instead of sine squared, I would write 1 minus cosine squared. And then if I multiply this minus sign in, this becomes minus plus cosine squared. And then what happens? Cosine and cosine are combined. I get 2 cosine squared theta minus 1. So another possible way of writing the same formula is this. It becomes 2 cosine squared theta minus 1. So don't think there are 3 formulas. No, that is only this formula. This formula is a mixture of cosine and sine. Sometimes you have access only to sine. It is better to use this. Sometimes you have only access to cosine. It is better to use this. And all of them are in the formula sheet. So these 2 are called double angle formulas. These 4 are called addition and subtraction formulas. I think this is the first lesson that is totally new. I mean, this is not a repetition of what we had before. But I agree. I more or less solved enough examples of these, but these are a little bit confusing. I will expend 1 or 2 more sessions to complete this lesson. Okay, any questions? Okay, thank you.